In this lecture video, we will talk about structural models. The main purpose of structural models is these are models of software display, and they display the organization system in terms of the components that make up the system. And they also display the relationship between the components that make up the system. Structural models may be of two types. The first one, or the first category, is static models. Static models show the structure of system design. The second category is dynamic models, and dynamic models show the organization of the system when it is executing. These are not the same things. The dynamic organization of a system as a set of interacting threads will be very different from the static models of just the system components. You create structural models of a system when you are discussing and designing the system architecture. Architectural design is a particularly important topic in software engineering, and UML component, package, and deployment diagrams may all be used when presenting architectural models. Let's take a look at the first structural model, that is the class diagram. Class diagrams are used when developing an object-oriented system model to show the classes in a system and the associations between these classes. Loosely, an object class can be thought of as a general definition of one kind of system object. An association is a link between classes that indicates that there is a relationship between these classes. Consequently, each class may have to have some knowledge of its associated classes. Class diagrams in UML can be expressed at different levels of detail. When you are developing a model, the first stage is usually to look at the real world, identify the essential objects, and represent these objects as classes. The simplest way of writing these is to write the class name in a box. You can also simply note the existence of an association by drawing a line between these classes. Take a look at this example here. So this is a figure which shows a simple class diagram having two classes. The first class is called as a patient. The second class is called patient record. As you can see, the UML notation is to write the class name within a rectangle. There is an association between the patient class and the patient record class, and this association is shown as a line drawn connecting both these classes. In this figure, a further feature of class diagrams is illustrated, and that is the ability to show how many objects are involved in the association. In this example, at the end of the association, you have the number 1 annotated, meaning this is a 1:1 relationship between the objects of these two classes. If I try to read it, it says each patient can have one record. Or if I read it from this end, I can read it as each patient record maintains information of exactly one patient. In this figure, what you can see on this slide, this is a kind of class diagram which shows that objects of class patient are also involved with a number of other classes. So these are all the classes and their associations, and these classes are of the mental health care patient management system. You can name the associations to give the reader an indication of the type of relationship between classes, and the UML also allows you to write the role of the objects participating in the association. So at this level, you can see that the different classes in the MHCPMS is consultant, patient, condition, general practitioner, consultation, hospital doctor, medication, treatment, and so on. So these are the various classes present in the mental health care patient management system, and you can see their associations. That is, if two classes are associated, then you can see there is a direct link between them, or a line joining the associated classes. So let's try to read this. A patient can be diagnosed with a condition. If you look at this number or this notation, which is also called as multiplicity, you can say that a patient can be diagnosed with multiple conditions. And if I read it from this way, multiple conditions, or a condition can be, the same condition can be associated with multiple patients. So patient can also be referred to a consultant. A patient can be referred by a general practitioner. A patient attends consultation. Consultation can prescribe medications. Consultation can prescribe treatment. And a hospital doctor runs a consultation. Let us pay attention to the annotation or the multiplicity at the end of the consultations. A patient can be, multiple patients can be one or many patients, or multiple patients can be referred to a single consultant. A consultant can have multiple patients he is consulting. A general practitioner can be referred by multiple patients. A patient can be referred by one general practitioner. A patient can attend more than one consultations, and consultation can have more than one patient. So a consultation can prescribe multiple medications. A consultation can also prescribe multiple or different types of treatments. A hospital doctor can run multiple consultation. A consultation can be made up of 1 to 4 doctors. That is, a consultation can have a team of 4 doctors, different kinds of specialists based on the condition the patient is diagnosed with. And also, a treatment can be prescribed over a range of multiple consultations. Medications also can be prescribed over a range of multiple consultations. So this is how you can read these class diagrams. So basically, class diagrams will depict all the classes involved in the system, and how you can link or show associations or connections between these classes, and the multiplicity which is annotated at the end of each association. Let's look at this side of the diagram or the slide. So this is a figure of the consultation class. So here, if you want to define your class in more detail, here I have taken only this class. So you can see there are 1, 2, 3, 4, 5, 6, 7, 8 classes, but I've taken just one class and tried to elaborate it or add more detail to it. So to define a class in detail, you can add more information about the attributes or the properties of that class, and operations that can be performed by any objects on this class. So if I take a consultation class, then these are the attributes or properties of a class, of the consultation class. That is, there are doctors, date, time, clinic, reason, medication, treatment prescribed, voice notes, transcripts, and so on. The dot 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 here indicates that there could be many other attributes, and only a few of them are listed here for convenience of reading. And there are, in the third compartment of the class diagram, what you can see is the operations that can be performed: new, prescribed, record notes, transcribe, and so on. So in UML, you show the attributes and operations by simply extending the class name by adding more compartments to this rectangle. So in the first rectangle, you have the name of the class, and in the second rectangle, you'll have the class attributes, and in the third rectangle, you'll have the operations. So this figure basically shows the possible attributes and the operations of the class consultation. So in this example, doctors may record voice notes here, and you may have to transcribe them later to record the details of the consultation, and so on. So this is about structural models and class diagrams in detail. So in this lecture video, you have understood what is a structural model and what is its purpose, and we have seen what is a class diagram and how to represent different aspects or different components of the class diagram in UML.